let us solve the examples of the topic, change the order of integration. Now here you are given, say, double integration fxy, say dy dx. That means limit of y is f1x to some f2x, x equal to say a to b. Now we need to change the order. That means here the order is first integration with respect to y and then with respect to x. So we have to change here that first integration with respect to x, say some g1y to g2y, and then integration with respect to y, say from c to d, fxy dx dy. Now from here to here, first step is draw the region of integration. Then, now if you want to take the first integration with respect to x, then inside take horizontal strip. And then find limits. And then solve the example. And vice versa. If here first x integration with respect to x and then y, then if we change the order of integration, then first integrate with respect to y and then with respect to x. Sometime it may happen that one side you are having like this, but other side that region is subdivided into two parts. So we have the region like this one. So we need to take this kind of integration when we change the order of integration. For sake of simplicity, we shall not take this kind of example. But this is very good topic in the sense that sometimes it is not possible or it is very difficult to integrate this way. But if we change the order of integration, the integration becomes very easy. So let us take the example. Change the order of integration and evaluate. Double integration x to pi 0 to pi sin y over y dy dx. Now see, if we directly integrate, then we need to integrate first with respect to y, and so we need to integrate sin y over y, which is not possible. So better to change the order of integration. So now to change the order of integration, first we need to draw the region of integration. So here y equal to x to y pi and x is 0 to x equal to pi. So let us draw the region. So here we have y equal to x line So this is y equal to x line. Then y is pi. So somewhere say here, this line y is pi. So this point is pi pi. This is a x equal to 0 and x is pi. So this is x pi. Okay. So the region of integration is this one. This is the region of integration. How to decide? Like y is x to y pi. So suppose if I take like this. So y is x here, y is pi. And x is 0 to x equal to pi. So that strip move horizontally from x0 to x pi. This is not the region, because if this is the region, then the limits of integration is like here y equal to 0 to y equal to x. Okay, so this is not the region of integration. So now to change the order of integration, let us take the horizontal strip. So to change so you can write the region of integration R is as shown in the figure. So to change the order of integration, let us take a horizontal strip, say PQ in R. So now we find the limits. So here x equal to 0 to here x is equal to, x is on this line, y. And this strip move from here to here. So y is 0 to y equal to pi. And so double integration x to pi 0 to pi sin y over y dy dx equal to x equal to 0 to y equal to 0 to pi sin y over y dx dy. Now y is constant, so this part is constant. So y is 0 to pi sin y over y integration is x 0 to y dy. So y equal to 0 to pi sin y over y, this is y dy. And now this y cancel. So we have minus cosine y 0 to pi. So that is minus cosine pi minus minus plus cosine 0. And cosine pi minus 1. So this is 1 plus 1. So answer is 2. So we can see that the most difficult integration to evaluate will become very easy when we change the order of integration. So next, change the order of integration and evaluate. So x to 1, similar kind of example, 0 to 1 sine y square dy dx. So here, this limit is of y as a function of x, y equal to x to y equal to 1, and x equal to 0 to x equal to 1. So let us draw the region. So here y is x. So y is x, y is 1. So somewhere y is 1, x is 0, and x is 1. So y is 1 here. So this point is y is x. So that is 1. So x is also 1 here. Y is x to y is 1. So this is the region of integration. And now here in this region, we need to take the horizontal strip. So the region of integration is as shown in the figure. Next, to change the order of integration, let us take a horizontal strip PQ in that region. So next is limits. Now here x 0, here x is y, and this strip move vertically from here to up to here. So y is 0 to y equal to 1. And therefore, integration x to 1, 0 to 1 sine y square dy dx is now, this is equal to x equal to 0 to y equal to 0 to 1 sine y square dx dy. Sine y square integration is not possible. So we take the change of order of integration. So y equal to 0 to 1 sine y square is constant. Integration is x equal to 0 to y and dy. So this is equal to y equal to 0 to 1 sine y square. This is y dy. And if I take y square equal to t, so 2y dy equal to dt, and y dy is 1 by 2 dt sine of t. And limit will not change because y 0, t also 0, y equal to 1, t is also 1. So t equal to 0 to 1. And so this is 1 by 2 minus cosine t, t is 0 to 1. minus cosine 1 minus minus plus cosine 0 is 1. So answer is 1/2 into 1 minus cosine 1. Okay, we take one more. Change the order of integration and evaluate. Y by 2 to 1, 0 to 2, e power x square dx dy. Now here this limit is of x. X is equal to y by 2 to x is equal to 1. You can say this is y equal to 2x. And y equal to 0 to y equal to 2. Now, if we take the region of integration, so y equal to 2x line we need to draw. So this is a y equal to 2x, x equal to 1 somewhere here. So x equal to 1, then this point x is 1 and y is 2. So this is 2. So the region of integration is x equal to y by 2 to x equal to 1, and that is from y equal to 0 to y equal to 2. So this is the region of integration. So the region of integration is as shown in the figure. Now to change the order of integration, let us take, now here we need to integrate first with respect to y. So let us take a horizontal strip, sorry, vertical strip. PQ in the region R. And now we find the limits. So here x is y is 0 to here y is 2x. And that strip slide horizontally from here to here. So x is equal to 0 to x is equal to 1. So therefore, double integration y by 2 to 1, 0 to 2, e power x square dx dy is equal to y equal to 0 to 2x, x equal to 0 to 1 e power x square dy dx. Now integration with respect to y. So e power x square integration is y is 0 to 2x dx. So x is 0 to 1, e power x square, this is 2x dx. And if I say x square equal to t, then 2x dx dt. And limits will not change. When x0, t0, when x is equal to 1, 1 here, so t equal to 1 square, and so that is 1. So this is equal to 0 to 1, e power t, 2x dx is dt. And so this is e power t, 0 to 1. So e minus e power 0 is 1. So this way we can evaluate the integration. Here the integration is not possible. E power x square integration is not possible. But if we change the order of integration, this will become very easy. Next video we shall take some more examples. Thank you.